With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
The given question is, in the following circuit, PN junction diodes D1, D2 and D3 are ideal for the following potential of A and B. The correct increasing order of resistance between A and B will be, now see, we are having three PN junction diodes D1, D2, D3 connected across the junction A and P. Okay, and we are given the node voltages or the potential at A and B respectively for three cases. Okay, and we have to tell in which of the three parts the equivalent resistance of the circuits will be. We have to arrange them in the increasing order. Okay, basically, and these are the given options we have. Okay, now let's start with the case 1, and before that let me tell you some basic things about the PN junction diode. Now see, this is basically a PN junction diode where this side is the P side and this side is the N side. Now if P side potential is greater than the N side potential, okay, that is if potential of P is greater than the N side potential, the diode will act as short circuit. Okay, will act as a short circuit, right? That means its resistance will become 0 ohms because it is given as ideal diodes. Okay, these are the ideal diodes. And if the potential of P side is less than potential at N side, then the diode will act as acts as open circuited. Okay, open circuit. And at that time the resistance of the diode will become infinite. Okay, that is, it will become a open circuit, right? So now further we have case 1. Okay, in case 1 we are given the potential at node A is given to be minus 10 volts. Okay, and at B we have minus 5 volts. Okay, now let me represent this in the figure. For case 1 we are having here minus 10 volts and here minus 5 volts. Okay, now we have to check the whether the diodes are on or off. Okay, so let's see now for diode 1. Now see, this is the P side and this is the N side here. Okay, and the P side is connected with minus 10 volts, right? This is connected with minus 10 volts and N side is connected with minus 5 volts. Okay, so for diode D1 we can say that the potential at N side is greater than potential at P side, right? That is, potential at N side is greater than potential at P side. So the diode, for see, this is the condition here, Vn is greater than Vp. So the diode will be acting as open circuit, hence it will give a resistance of infinite ohms. Okay, so D1 will be open circuited. Okay, let me write here, it would be open circuited. Next is we have D2. Okay, now see, D2 is connected in the reverse order as that of D1. So now if D1 is turned off, so D1 will be turned on. Okay, because see, in this case this is minus 5 volt, this is minus 10 volt, and the Vp is greater than Vn. So D2 will be on. Okay, because Vp is greater than Vn, so it will give a resistance of 0 ohms, right? And similarly we have diode D3. Now see, diode D3 is connected in same fashion as that of D1, so it will be open circuited. Okay, the reason is that same is for D3. Okay, so D1 and D3 will be open circuited. Now if I draw the circuit diagram again, we have, see, this is the resistance, that is R by 4 ohms. Further we have three branches. So branch 1, this is infinite, connected in series with R ohms. This branch is short circuited, the middle one, okay, with resistance R ohm, and here also it is open circuited. Okay, this third branch, and this is R ohm. Okay, and further we are having here R by 4 ohms. This is connected between A terminal and B terminal. Now in this case, if I have to find the equivalent resistance, then see, we have R by 4. Okay, then this R and this R by 4, all three resistance connected in series because no current will be going in these branches. So we will have R equivalent equals to R by 4 plus R by 4. So this will be equals to R plus R by 2. So R equivalent for case 1 will come out to be 3R by 2. Okay. So this is for the first part. Now we have for second part. In the second part we are having just reverse the voltages. Okay. We are having the case of just reverse. That is VA is now minus 5 volts and VB is now minus 10 volts. Okay. It is just the reverse of case 1. So now as the voltage are reversed, then the polarities also for the D1 and D2 and D3 will be reversed such that now D1 and D2 will be acting as short circuited. Okay, because D1 and D3 will turn on. Okay, D1 D3 will now turn on and they will give a resistance of 0 ohms. Okay, and for D2 it will get turned off. It will get turned off and it will give a resistance of infinite ohms. Okay. So let me again redraw the circuit here. We have the resistance R by 4 ohms, okay, connected with the three parallel resistance branches. Okay, we have D1, D2 and D3. See in the figure, we are having minus 5 volts at A side. Okay, we are having minus 5 volts as A side and minus 10 volt at B side. So now see here, this diode will get short circuited because VP is greater than VN. Diode D2 will get open circuited because VN is greater than VP. Okay, see here we are having minus 5 volts. Okay, minus 5 volts, and here we have minus 10 volts. So VN is greater than VP, and similarly for D3, the VP voltage is greater than VN voltage. So D1 and D3 will be acting as short circuited. Okay, so this I will short circuit, and further we have resistance R in series in all the three branches. Okay, this is R and R. Further it is R by 4 ohms. Okay, R by 4 ohms, and this is in between A and B. Now see, to find the equivalent resistance between A and B, we have R equivalent would be equals to, this is R by 4 plus we have, now see, these two resistances will be in parallel. Okay, this R and R, so it will be R will be parallel with R, plus in series we have R by 4 resistance. Okay, so now if I find the R equivalent, so R by 4 plus R by 4 will be R by 2, plus for this parallel combination we will have R into R divided by R plus R. Okay, so this will give me R by 2 plus this whole combination will be also become R by 2. So R equivalent in case 2 will be come out to be R ohms. Okay, so this is for the part second. Next we have in part C, the voltages are minus 4 and minus 12 volts. Okay, in part C we have VA potential equals to minus 4 volts and VB potential equals to minus 12 volts. Now see, here we are having minus 4 volts and this is minus 12 volts, minus 4 minus 12. Now see, the condition of the diodes will remain the same only, right? Because in this case also, see for D1 VP is greater than VN, right? It will be short circuited. In for D2 the VN voltage is greater than VP, so it will be open circuited. And in for D3 diode we have VP is greater than VN, so it will be short circuited again. So the same circuit will follow, this same circuit will follow for this part also. Okay, let me draw the circuit. This would be R by 4 plus we have D1 shorted, okay, D2 open circuited, then again D3 short circuited, and we have three resistances. Okay, further we have R by 4 ohms here. Okay, this is R, R and R. So between A and B terminals. Now see, as the circuit diagram for both the parts are same, then the equivalent resistance for this part will also come out to be same. Okay, that is R ohms. Now we have to arrange the equivalent resistances in the increasing order. Okay, so for the part A, we can write the equivalent resistance came out to be 3R by 2. For part B, it came out to be R. For part C, it is also R. So from the options A, B, C, and D, we can see that the part third and the part second are same. Okay, so part 2 is equals to part 3, and this is less than part 1. So this is the correct option, and this is the option in part C. So option C is the correct option. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.